Welcome my friends. In this video, we will be going to discuss our topic, that is all the places where patterns can be used. Patterns pop up in number of places in Rust and you have been using them a lot without realizing it. This section provides you with a reference to all the places where patterns are valid. First, we will be discussing about the match arms. So we have used patterns in the arms of match expression. Formally, match expression are defined as the keyword match, a value to match on, and one or more match arms that consist of a pattern and an expression to run if the value matches that arms pattern. So how our match pattern works? So I'm showing you an example. So our match pattern looks something like this. We write match, then we give a value to it, and then inside it, what we have, simply we give a pattern, and then after pattern, we give a expression. So one requirement of match expression is that they need to be exhaustive, in the sense that all possibilities for the value in the match expression must be accounted for. One way to ensure you have covered every possibility is to have a catch-fall pattern for the last term. So a particular pattern, that is this. So this will match to anything, but it never binds to a variable. So it's often used in last match arm. The underscore pattern can be useful when you want to ignore any value not specified. So we will be covering this pattern in more detail in our upcoming videos. Now we will be seeing how we use patterns in our conditional if-let. So we have discussed how to use if-let expression mainly as a shorter way to write the equivalent of a match that only matches one case. Optionally, if-let can have a corresponding else containing code to run if the pattern in the if-let doesn't match. So now we will be creating a program where we will be matching all the possible values with if-let, else-if, and else-if-let expression. Doing so gives us more flexibility than a match expression in which we can only express one value to compare with the patterns. Also, the condition in a series of if-let, else-if, and else-if-let arms aren't required to relate to each other. The code that we will be creating will be showing a series of checks for several different conditions that decide what the background color should be. So we will be creating a variable with hard-coded values that a real program might receive from user input. If user specifies a favorite color, that color is the background color. If today is Tuesday, the background color will be green. If the user specifies their age as string and we can parse it as number successfully, the color is either purple or orange, depending on the value of the number. If none of these conditions apply, the background color will be blue. So now let's write the program on this condition. So what I'm doing, simply I'm removing this. Now in my main function, simply what I will be doing, I'm creating a variable, let favorite color, and here I'm specifying option. So initially I'm storing none in it. Then I'm creating another variable that is Tuesday, and I'm storing false in it. Then I'm creating another variable named as age, and it will be of result type, and the OK will be of U8 type. Then here I'm using this underscore pattern, and then after it I'm giving a value to it 34, and I will be parsing it. Then after it, simply I will be writing my if conditions. So here I'm writing if let sum, and then here I'm checking if my sum color is equal to my favorite color, and inside it I will be printing using your favorite color. Then printing the value, and here I'm writing as background color. And now in my else block, I'm checking if it's Tuesday, then I will be printing Tuesday is green. And after it, I will be using another else if let. So here I'm writing else if and then let, and here I'm just writing OK, then age, then equals to age. And then inside it, I'm checking if my age is greater than 30, then simply I'm printing using purple as the background color. Else if it's not true, then I will be printing using orange as background color. And in my last else, I will be just writing println, then here I'm writing using blue as the background color. So now here in this program we have mixed if let, else if and else if let and else also. So this conditional structure let us support complex requirements with the hard-coded values we have there. This example will print using purple as the background color if I compile it now. So I will be compiling it. Our program is compiled. And it's working. And our answer is using purple as the background color. So how our program is working? So first I have just encoded my none in my favorite color. So this condition will be going to fail because it will be going to check if there is something in my option enum, but in my option enum I have none. So after it will check if it's Tuesday, but here I have specified false. So in the else condition I have used if let, and here I have written okay age equals to age. And then here what I have done, simply I have checked whether my age is greater than 30. So if my age is greater than 30, I will be printing using purple as the background color, and my age is 34 as you can see. So this else condition will not be going to execute. And now if I just put any value here, suppose here I'm writing some red. Now let's try to compile our program again. It's compiled, and this time our output is using your favorite color red as the background. So here we have specified some value, so this condition will be going to match. So in this program you can notice that here I have used the shadowing. So you can use if let that can also shadow variables in the same way that match arms can. The line if let okay age equals to age introduces a new shadowed variable, that is age, that contains the value inside the okay variant. This means we need to place if age greater than 30 condition within that block. So the downside of using if let expression is that compiler doesn't check exhaustiveness, whereas with match expression it does. If we omitted the last else block and therefore missed handling some cases, the compiler would not alert us to the possible logic bug. So now that's it for this video. Meet you soon. Goodbye.